Okay. So this course will follow that course little bit, which will be little bit similar, uh, and we will start with Scratch. And using Scratch, we can get many of the fundamentals, programming fundamentals, because programming is to teach a computer how to do something, because the computers are powerful, but without teaching them, or uh, they cannot do anything by themselves, at least for now. Okay, but in future we don't know, but we have to teach them how to do it. So we have to teach them in a language or in a way that they can understand. So it is different teaching humans and computers. Okay, so to teach computer, we have to think like a computer. Okay, so that there's a difference. Okay, so all of you have passed done mathematics, physics. Okay, and so you are very well. I mean, you can do lots of computations, ma- arithmetics, algebra, geometry. Okay, and then some physics. Okay, and so this is you know the logics behind science. Okay, so you can solve a problem. Okay, but solving a problem with computers is different, so you have to think like a computer, so it's a little bit different. So that is why many people uh, cannot start doing computer programming, because it's different thinking. Okay, so you have to think like a computer, and so to do that you have to uh, program. Actually, you have to do it. Okay, so the problem with doing it is with a uh, language like Python or C or C Sharp, Java or JavaScript or whatever, is it's very difficult to get it started. So when you write a program, you can make spelling mistake because you have to type it. Okay, when you type it, you make mistakes, and when you make mistakes, you get errors. You cannot run the program. There will be errors. Okay, so then since you don't have any programming knowledge before, okay, prior to this, and you will not be able to solve that problem. Okay, so then you get discouraged, and it will be a vicious cycle. So you will the final uh, situation, the result will be you quitting programming. So you will give up programming. But with this visual programming language, you cannot make mistakes. Okay, you don't type, you just drag the blocks, and then you assemble or build your program like a Lego blocks. Okay, and this is very easy, and nobody can make mistakes. If you do that, the program will run, it will not crash, at least. Okay, and you will not get the correct result, but it will run, it will do something, and then you can learn these fundamentals easily. So that is why I have chosen this framework, or this Scratch framework, to teach you computer uh, programming. Okay, and when you are following this course, you have to go through this uh, LMS. So I have so the next topic will be C++. So I will be start after going through Scratch and fundamental of computing. I will go through C++. So then you can see how you can convert your Scratch code into a proper uh, program written in C++ or any other language. Okay, and I have put some materials how to get it started. Just go through it if you have time, and try to set up the environment. So if you have Windows, try to use Windows. There are so many options for Windows, and if you can install Linux in your laptop as a dual boot, maybe, or in a virtual machine, if you have a better computer, try to install Linux. I mean, it will teach you a lot of things. Okay, by installing itself will teach you a lot of stuff, and you have to play with your computer. If you are becoming an engineer, and any engineer, not only computer engineer, you have to be very knowledgeable about computers, how to install softwares, how to format, and just try to install Linux. And if it destroyed your Windows, try to, I mean, do it again. Okay, so there are so many tutorials in the YouTube or in the internet you can follow, and if you know how to do it, it's and Linux is not difficult. Sometimes you may be not able to connect to Wi-Fi or your ADSL machine or whatever. Okay, ADSL the router. Okay, so you will learn a lot of things by installing Linux, not like Windows. Okay, so try to do it if you like to learn. And there are so many editors. I have used CodeBlock is the simplest one. You can run in Windows, and if you are Linux, there are so many options. It's very easy. And then I have put some tutorials and books. Uh, and if you have, I mean, not now, I mean, just try to learn by yourself. I mean, in computing, you have to learn by yourself. So after maybe going through the scratch, the first part, you can uh, the people who are more interested can move into the next topic by your own. That would be very good. Uh, so it is what you have to do. I mean, you have to learn by yourself. Okay, and then we will be having some introduction to competitive programming later, and then this HTML and CSS and JavaScript as well. So I will teach you the JavaScript, the basics of it, because there are so many things you can learn, and this is a must. Okay, now I mean most of the uh, applications now are not in desktops. I mean very specific ones like MATLAB and those kind of Word. I mean MATLAB, those kind of engineering softwares are only in desktops. Okay, all other softwares, even Word is you can run online. Okay, and Excel, Google Docs. There are so many online applications. I mean, almost all applications are online, run in web browsers or smartphones. Okay, so if you want to develop those kind of applications, you have to learn the basics of web development, and HTML CSS is the starting point, and JavaScript also. So if you uh, so I will add some materials on JavaScript as well here, and so you can learn by yourself, and I will also teach you some basics during this course. Okay, and then so I have put some resources. Okay, and you can just try. If you are an engineer or special computer engineer, we want to listen to others. Okay, and the new technologies. So there are so many events going on in the world, like Microsoft built symposium, and then Google they have once a year they are having their own symposium or conference to discuss new stuff, uh, and there are the other people as well. So just be aware of them and just try to listen to them, and you will know that the new technology is coming up, what are the things are coming up, and if you whether you it's worth learning them, and so on. So just so I have put one keynote which happened last month, build conference by Microsoft CEO. So there are those previous conferences as well. Maybe you can go and listen to 2019, 20, those kind of conferences, and see what they have done in different technologies like Android, Apple, iOS, Windows, and languages like Java, C Sharp, and JavaScript. Um, so just listen to them, and you will. The one thing is when you are listening, you will improve your English as well. English, and sorry, I will come into that. And then just listen to the other people. Okay, especially since you are interested in computer engineering, listen to the people in computer, the big guys, okay, like Bill Gates, uh, Steve Jobs, okay, and there are so many people who have given interviews in the internet, and just read about them, how, and the Facebook, Mark Zuckerberg, okay, and they have done some talks like commencement speeches in university graduation. There are so many nice speeches by all of them, and just go and listen to them and the interviews. So Satya is the current CEO of Microsoft, and you can see how his interview, this interview, just go and listen to them and how they started. So they are from India, so it's so they are the people like you, okay. I graduated from IIT, and the Google CEO also an Indian who graduated in India and then moved to US for higher studies and jobs. So just listen to them and how they uh, went through their careers and how they invent their uh, products. Okay, so you will learn a lot of things from them, and then you have to improve your English. Okay, that is a must. So there are channels in YouTube. One is TED Talks. You can listen to them and then can see how other people are talking, especially public speaking. Okay, try to practice them. Okay, just so public speaking is very good way of improving. I mean, you have to improve your speaking and uh, oral communication and written communication as well. Uh, so so you can uh, listen to them, and maybe you can do your own, and you can record yourself and see how you are doing, because unless you record yourself you cannot see your mistakes. Okay, so recording yourself by a webcam or in your laptop or using your phone, and see how you can do, I mean, what are the mistakes you are doing, and so what are the problems you are having. So just do a talk similar like tech talks or on any subject, and try to record yourself and try to improve every day, maybe once a week you can do this. And then you have to learn the basics of English, okay, the grammar and the pronunciation and uh, sentence structures, okay. So you can listen, there are so many great channels teaching you English. There are two main variations of English: British English or American English. You can follow whatever you want. Okay, just follow one, but you can listen to the other stuff as well. So the grammar is same almost, but the spelling and the pronunciation is different. But you can follow any variation. Okay, and any channel. There are different channel for different English. Okay, so English and communication is important, and just try to read books and novels, like, and improve your vocabulary as well. So there are softwares to improve your vocabulary. You can save your new words, and in Android or iOS you have so many vocabulary softwares, so you can use them. And then after that you can there are so many tutorials. So I have chosen one tutorial series by Microsoft, but I chose that. You can choose anything. You can choose anything. Microsoft Stack or Microsoft is uh, easy to learn. Okay, the C Sharp language is awesome, one of the best languages we have, and they have their uh, everything is integrated. But if you learn something like Java, there are so many frameworks by different people, and you will be lost which one to choose, uh, like that. So you can, if you learn one set of tools, it will be very easy for you to move to another tool set like JavaScript or Java or any other uh, frameworks. So they are almost similar these days. Okay, so you can follow them after maybe going through this series. Okay, lectures. Okay, so we will be starting with this one, and I will go through this. So you can see now most of you have gone through LMS module and just use it uh, to your maximum. Okay, the people who have not registered, please register and go through it. And then did you try Scratch? Okay, okay. Many of you haven't tried the Scratch. Only 19% is have used it. And then how do you find it? Okay, many people, few people have said it's too simple. Yes, it is too simple, and some may have said it's too hard. They are almost same. So uh, uh, we will have same number of people who are saying too hard or too simple. Okay, and then most of you are thinking that is helpful. So we will be starting with Scratch. Okay, do you have any problem questions? Okay. So there's a question, should we install JavaScript? So you don't want to install JavaScript. It's already there if you have a web browser. And I will let you know how to use it later. So don't, I mean, if you are interested, you can follow the tutorials in the internet. But don't try to do everything at once. Okay. If you are uh, 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 if you are a experienced programmer who knows the fundamentals, you can do. But if you don't know the fundamental, we will start with Scratch. Concentrate on Scratch right now and just try to learn the basics. Okay, so there's another question, what is the difference between C and C++? So they are almost same. C is the one which came earlier, C++ came later, so there are different advanced stuff. And C, it's not object-oriented programming language. It's called structural programming language. So, uh, so, so there are differences between that. But if you use C++ compiler, okay, you can use all uh, the stuff in C. Okay, so C++ is the C is included in C++. Okay, C++ is C plus something more like object-oriented stuff like classes, interfaces, those kind of stuff. So we will not go into that, but I used C++ because it's the same. So you can learn C uh, and C++ at the same time. I mean, you don't want to learn them separately. Okay, you can use the C++ compiler to do complete. I mean, only C. I mean, C languages, C programming. Okay, so that's so that is why I use C++. So everything you can do in C, you can do in C++ and something more. Which compile is best for C++? Okay, it depends. Okay, I use GCC, the free compiler, so which is uh, usually written for Linux. And now they have ported into Windows, and then you have WinGW compiler for Windows, and then Microsoft C++ compiler, and then you have Intel. There are non-free compilers which you have to pay. Okay, and but the free compilers are totally fine. it doesn't matter. I mean, which one is best? Okay, anything which support the latest standards. So there are different standards like C++, 14, 17. So the language is evolving. Okay, there are new standards coming. So the C++ we used in 80s is not what we are using right now. So it is the ones in 80s is supported by now, the modern compilers, but they have new stuff. Okay, so C++ 17 is, and there's an upcoming another version of C++. So they are improving the language. Okay, so it doesn't matter uh, which compiler you are using, as long as it's a standard compiler. Okay, uh, there are standardization. So there's a body which standardize the C++. Okay, so if it is a standardized compiler, it doesn't matter which one you use. Any C++ compiler is fine. You can use anything. Okay, as long as it supports the standard C++, latest one. Okay. Uh, okay. So any other questions before we move to the real stuff? Okay, we don't have a problem. So now we will move into a Scratch. Okay, so when you move into Scratch, okay, so we'll the when you search Scratch in the Google, you will get this Scratch .mit.edu, and that is the one you want to use. And when you click that one, you will get uh, a web page like this. And here you can press create. So first you have to, if you don't have an account, you have to create an account. Okay, so I have already created an account. So it's very simple. Okay, so you need an email and password, and that's all. Okay, and if you have already logged in, created an account and logged in, you will be having something like this. So first create an account, and then log in, and you will come into a place, a web page like this. Okay, and then here you can create create, and then you will have a new project like this. Okay, so this is the project interface. So I will move this one here. Okay, so this is a visual stuff. Okay, so you can see uh, so there are blocks here, so you can drag and drop these blocks, and you can move them, delete them, and then you can drag any other block here, and you can delete them. Okay, so that is how we are programming. So there's a cat, so you can change this if you want. So you can, there are so many ways of doing that, and have rabbit or um, anything you like, car or anything. Okay, so there are so many. So only thing you have to do is and upload a small image like this, and I will change the size of this scat because it's too big. So I will make it 50 the size, otherwise it's cover the whole screen. Okay, and then you have different sections. Okay, different blocks. So they have divided into sections like motion, look, sound, events, control, uh, sensing, operators, and variables and blocks. Okay, so this is how you do it. Okay, so when you use a computer program, so computer program is consists of usually three components. Okay, So to write a computer program, you need these three components. First one is data. Okay, you need data in a computer program. Okay, you may need to remember your answers, or you want to uh, take inputs from keyboard or mouse or microphone or whatever, internet, network, and you have to save them and modify them and so on. So you want any program will have section for data, and then you have sections called expressions, like so print something or get input from a user or add these two numbers. So these are expressions. So you do, they are like operations. The computer will do those, run those expressions, and they will do something. Okay, print, and you print this, print your name, or add two numbers, or multiply two numbers. So these are expressions or operations. So any computer program will have consist of these expressions. Okay, and then you have a control flow. Okay, how do you implement these expressions? Okay, so you can implement them one after the other, you can implement them parallelly. So there are so many ways of your flow of your program. Okay, so when you program get larger, the flow will be very advanced, and so you have to think very well on this control flow of your program. So these three sections are there. So when you see a simple program in Scratch, so I will explain this stuff. So you can see we have three expressions, so three blocks. So these, one of these is an expression. Okay, so we have three expressions. Okay, and then we have data. So data is basically this cat. So cat is the data in our program. Okay, it's an object, so we have to save, or we have to save it in our program, and the program will do operations or using expressions on this cat. Okay, so when you can, so this pure English, when this flag is clicked, you move this cat 100 steps forward, and then you turn 90 degrees, and it will turn this way. So 90, you know the angle. So this is a simple program, and you have three steps, and this control flow is you implement one after the other. So you first implement this one, next this one, next this one. So that is the flow of your program. So we call it control flow, and you have data and you have expression. So you have these three components of your program. So any program will have these three components. Okay, so when you design a program, any program, you have to think what expressions you are using, how your control flow should be, and what kind of data you want to use. Okay, so this is how you design your program. So any program will have these three components. Okay, okay, let's move into our program. Okay, sorry. Okay, so we will go into more motion, and first events. So in the event section, you have this block. I will make it a little larger. So it says when, so it's an event. So there's a flag here. When you click that flag, this block will be executed. Okay. So I want to move this cat to a place called, so this is a coordinate, you have a Cartesian coordinate system here. You have X this way and Y this way. And maybe 0, 0 is in the middle. Okay, here. And so I want to move this cat to this place. Okay, so I can move here, and then when you click the flag, the cat will move to the position 0, 0. So my program has one expression. Okay, so it will go to the uh, that place. So, and then you go to the place and uh, move to the direction. Okay, so I put another block and you can drag that block and fix it here. So now this control flow will start from here, and first it will execute this one and then it will execute this one. The first one says go to 0 0, so I will drag to a different place and then point in the direction 90. So 90 will be maybe this way, I don't know, we'll see. So I will change the rotate the cat to make it more visible. So you go and you now you are uh, pointing the direction of uh, this way. Okay. Okay. So since you cannot see this because everything happens at once and the computer is fast, so the computer will execute these uh, uh, expressions very fast and you cannot see it. So I will make some wait, maybe at events. There's a wait command, yeah, controls. So I will put some wait 1 second here and wait 1 second here, and to make it, so I will change it like this and move it. So now you can see these commands executed one by one, because after uh, executing this command, you wait 1 second before executing the next command. Okay, so now you can see, so you can see here. So when I click the flag, so you go to this place and then after 1 second you change the this one. So again I will do that. Okay, move, change. Okay, the direction. Okay, so so this is our control flow now. So you start execute this expression and then you execute this expression and then you execute this expression and then this one. Okay, so any questions up to here? Any question about uh, expressions or control flow or data? So we have only one data, which is the cat. So if you don't understand anything, the time period. So when you move, it's very fast. So there is another one called glide. Okay. So glide is, if you use glide, you can change the time period. Okay. So now, so I will, so now the control flow is like this. So you start with this and then wait 1 second and then this one. So this expression is out of the control flow. So it will not be executed. Okay. So this is out of the control flow. So I will rotate this one and now you can see now it is moving slowly and after that you change. Okay. Can we change the values inside the motions? Okay, I don't understand the questions correctly. So you can change the values. Okay. Uh, your meaning of these values? I don't know. Okay. So you can change those values. Okay. And I'm not sure whether what okay. Uh, uh, so I don't have sprites here. So you can yeah, choose a sprite here and you can choose an apple. okay, instead of sprite. And now when you select the sprite, okay, so this is how they have so for this one you have this program for this sprite, and when you add a new sprite you will have a total new program for that sprite. And for that sprite, so you can go to the events, again you can write another program for that. Okay. Random position. Okay, so now, so I will move this one here. Okay, now, so there are two programs. Okay, so one is for the cat, the other one is for the apple. Okay, so click that one. So now you can see both are moving. So it's go to the random position. Okay, so this one is go to the random position. So you can change to the mouse pointer if you want. Okay, so it since random position is better. Okay, so now if you do it, it will be something like that. So if you can add any number of sprites. So there are different sprites. Okay, here, and you can use those sprites, and for each sprite you can have different program, different control flow. Okay, so these sprites are independent, and but you can communicate between sprites. So we will see later how to do it, but up to now you want to learn to program one sprite. Okay, so I will remove this sprite. Okay, so I will have only the cat. Okay, so there's no need to include the this event. So there are so many events. Okay, so I just click when flag is clicked. Okay, but there are some other events like when space key pressed or any key press events. Okay, so you can use that one instead of this. Okay, so now if you press space, I will, okay, when you press space now, it will happen. So now this will happen with space, or if you press 0. Okay, we are here. Okay, so you can use any event. So there are so many events. Okay, so you can see when spike clicked, when backdrop switch to backdrop 1, or when I receive a message, you can send message between these sprites. Okay, so there are so many events. You can use them, but for me it's easy, and you can to use this click button, because you can see when I'm pressing it. Okay, otherwise you will not be able to see it. Okay, okay. Any other questions? Yes, there is another question about offline mode. You can install, you can download Scratch. Okay, so you can download it for Windows, Mac, Chrome OS, or Android. Also there. Okay, so this is you can do offline as well if you don't have internet or if you don't have data. Okay, but I'm not sure whether you have all the features in it. So download Scratch 2 offline editor. Okay, all have. So you can, if you don't want to use data, you can use the offline editor, you can install it uh, easily. Okay, any other questions? So you can create your own sprite as well. Okay, somebody asking about vector images. Uh, I'm uh, I'm not sure whether about the format of the upload. So you can upload. I can remember how there's a place to upload as well. But there are enough. If you want to, so you can paint here and develop your own sprite as well, and you can change the sprite if you want. But so to create your own a game or anything, any app you can use. There are so many sprite, enough to create something very creative. Okay, so you can use anything you like. Okay, so I will use the beetle. Beetle may be better than the cat. Okay, so I can remove the cat and use the beetle, and I want to make it a little bit smaller. Oops, sorry. Okay, so I will be using beetle instead of cat because it's the direction is better. With the cat, it's standing straight, but the beetle is uh, uh, aligning with the direction you are going. So it's better to use a beetle for the next uh, uh, assignment or next section. Okay. Any other questions? So end of this section, I will ask you to create something very creative. So you can create games. You can have multiplayer games. So there are so many things you can do. Just create one very creative game. You can have soccer game or anything, shooting game, uh, even a fish tank with several fish communicating with each other. So there's you can have your own imagination. You can have scientific stuff, whatever. So try to create one very creative project by yourself, and you can say you can post your. So I will let you know where to post your project URL so we can see them, the creative. So just so end of this section, I will ask you to create uh, one by you. Okay. Any other questions? Okay. So we are moving only. So I want to draw using this beetle. Okay. So uh, so we can move. So we know that we saw that now how to move a sprite, the creature. But I want to draw stuff using this one. Then it is very easy for you to see how it is moving, and you can create some patterns using this one. Okay. So to draw, you cannot use these are the standard blocks you have. So to draw, you have to import extra blocks. I'm not sure whether you have them in the offline version as well. It should be. So there's this add extension button in the bottom left hand corner of this uh, editor. So you click it and extension. There's a button called in the bottom left hand, and when you click that one, so you will have some extensions. You will be needed. So you can have music player, music instruments. You have a pen, video sensing, text to speech, translate, make beat. So there are so many stuff. Okay. So to connect with the Lego mainstream robots, so you can do program Lego robots if you have one using uh, visual programming. Okay. So I want to draw some stuff. So I'm using this pen module, and so now in the pen module will be inserted in my blocks of modules. Okay. So here I can put the pen down, pen up, change the pen color, uh, uh, then set the color, change the size, okay, or something like that. There are so many things you can use to draw stuff. Okay, so there's a question: can we develop a small game by this application? Yes, you can. So try to do it. Okay, so then you can improve your creativity. So try to make something fun. Okay, so I will then we can then uh, post it, and maybe we can vote by ourselves and see which one is the best. Okay, Mm, the best creative or funny, and you can play others ones as well. Okay, try to uh, and then the book I have uploaded. There are so many. It's a complete books, I think. You can do. You can so the book. Uh, this book. Yeah, this book I have uploaded. Okay, so here it's uh, I think it has almost all these. Okay, so it's here. So motion and drawing, look and sound, procedures, variables, decision making, repetitions, string process, list. Okay, uh, so it's a very good book. Just to try to follow it. I will also discuss these stuff later, like variables, and so I will not go into uh, more details about looks and sounds, those kind of stuff in this one. And but you can read about it if you are making a game. You want to know them. I mean, you have to play with sounds, videos, and looks, okay, and how to communicate between different sprites. So using these, you can develop a game. Try to do it. So this is your task actually, making a game, or it can be a game or anything. Okay, very creative. Okay, everybody should start thinking. First, you have to learn what is there, what can be done using Scratch. You cannot do everything, but you can do many things. Okay, just see, and there are some. If you go to a uh, Scratch, and you can see the features projects as well, what others have done. Okay, so don't copy them. I mean, you have to. I mean, if you so then the main thing about learning is not copying. I mean, if you copy, you will not be able to learn. I mean, don't try to uh, copy or imitate. Just try to think something totally different. Okay, something fun. Okay, um, so that will improve. I mean, you have to be creative as engineers. You have to be creative. So try to think something fun. Try to think something out of box. So I mean, so all these projects, the games, there are simple games like Minecraft. So if you take Minecraft, it's very simple, but it's one of the most popular games and one of the most, uh, I mean, popular game, and it will generate a lot of revenue as well. And then so if you get a new idea, you can develop your own game and put in your Android Studio, whatever, Android App Store, uh, and you may be having a good company. I mean, game. I mean, it can be. I mean, if people like it, we don't know. The people like simple stuff. Okay. I mean, if you have a very good idea, the people easily get bored with existing games. And if you have a very good idea, the people will like it. If they like it, it's it. Okay. So try to create something uh, creative. Okay. 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 So now we will see how to do it. So we will put an event when this is clicked. Okay. So we are programming with this beetle. Now move to say, so yeah, move, go to say 0, 0. Okay. And then I will go to pen and pen down. And then I will move. So I will wait a little bit because so control, you have to go to the controls to find the wait. Wait 1 second, because otherwise you will not see, okay, what's happening. And move 10 say 200 steps. Okay, so move block, it will move in one direction. Okay, so you can move forward or backward, that's all. And before moving, I will change the direction as well. Okay, so the move step will be moving to the direction you are pointing. Okay, so now there are about say 1, 2, 3, 4, 5 expressions in this program. I will move this one. I will change a little bit, and then I will press this one, and you can see it draws a line when it is moving, because you have put your pen down. When you put your pen down, it will draw, and if you put your pen up, it will not draw. Okay, so using pen up and pen down, you can draw. Okay, so now uh, I want to draw a square. Okay, so I will start with maybe with y maybe 100 minus 100, because it seems it's too high. Oops. So now you saw that there's an issue. Okay, so you put this pen down here, and you move it to here earlier, and then I asked to move to 0 minus 100. When you are moving, it start drawing because your pen is down. Okay, so it's better first make the pen up. Okay, and if you have something drawn earlier, I want to erase them all. And now, okay, now you can see, maybe I will start with minus 100 as well. Oops. Okay, so now you can see, otherwise you will not be able to see it. Okay, so now you can see it draws while moving. So now I want to change the direction. Turn counterclockwise 90 degrees. So I will make it a little bit smaller, and then move again. Maybe I will wait a little bit, otherwise you will not able to see it. Okay, what I'm moving. So I will put somewhere here. It will move here. Wait 1 second, and you can see you can start drawing your using this beetle. Okay, the enrollment key I have sent you in an email. I will send it again. I can remember exactly for the course. Okay. The first email I have sent you the key. Okay, and then we want to draw again from here to here. So you have to turn again. So I will wait another 1 second. I will make this smaller a little bit. Hope you can see it. Okay. Again, you have to first turn. So you go to the motion section, turn anti-clockwise. So how many? How much? 90. Increase, and then move 200, and maybe wait and again. So 1 second. So now we'll see. Okay. So you can see now I have drawn 3 sides, and I have to draw one again. So first I have to go to motions and turn again counterclockwise 90 degrees, and then move 200. Okay, so now I have completed drawing the this one. So I will go to the pen. Maybe I will set the color. Set the pen color. Okay. Delete that one. So you can make a random color. I think you can make a random color. Okay, it was there earlier. Okay, so you cannot. Okay, we can make it random by using a random number. So I will do it later. Maybe you can change the color right now to green. Okay. Okay. So I'm maybe green is maybe red. Okay. Okay. Now, so we do it like this. Okay. So I mean, can we draw this? So you have the control flow like this now. So we have the control flow start with this one, this 2, 3, 4, 5. So it's a linear control flow now. So start with here and ends with here. So can we draw this square using another way, another method? Any answers? So you can use the chat if you want to answer the question. So can we use another control flow, another way of flow? So this flow is linear. Can we use another way of drawing this? Yeah. So we can use, so you can see the same thing is repeating here. Okay. So you can see move, wait, and turn. Move, wait, and turn. Move, wait, and turn. Okay. So that thing is repeating. Okay. So since it is repeating 4 times, move, wait, and turn, move, wait, and turn. Okay. So you can use a repeat control flow. So there's a control flow for repeating instruction. So now the control flow is flowing starting from here and moving it to the bottom, okay, linearly. But you can use a loop for this or repetition. So you can go to the control section and there are controls like wait, repeat, forever, and there are some other things. And I will use this repeat now. Okay, I will remove this part now, and I will keep it here for reference. I will put it here. Okay, I want to repeat, so I have to draw the same thing here 4 times. I have repeated, so I will repeat it 4 times. Okay, what do you repeat? Okay, so you can wait first or wait last, or it doesn't matter. And so first, first you have to point into the direction. So in that one you don't want to repeat. First you have to. So now you first you have to point into this direction. Okay. So that part you don't have to repeat, otherwise it will be a problem. Then you wait for 1 second, and then what you do is you move 200 steps. Okay, so what will happen if you do it now? Okay, it will move. Okay, so since and after moving, what you want to do is you have to repeat this turning as well. How much you want to turn is 90. So now, so you have this four repetition of wait, turn, and move. Okay, depending on how you do, you can change it. So first I am pointing to this direction, and then move, and then turn, and now we will see how it will look like. Turn. Okay, so now you can repeat the same instructions like this. Okay, so now uh, can you draw something else like a uh, uh, like a octagon? So what do you want to change? So I want to draw a I will draw a octagon. Or so what do you want to change? So you can the place you want to change. So you can answer it in voice or even using chat. What do you want to change, and where do you want to change? So this is a square, and I want to so a regular hexagon or pentagon octagon, something like that. So where do you want to change it? Anyone? Yes. You want to change the angle, okay, and the number of sides, okay. So you can you have to change the degree, so then the way of turning. So if it is a so now it is 90 because we have 4 sides, and if it is 8 sides, how much we want to turn, okay, is the problem, okay. So we will see, say, so we will make it 45 and 8. So this will be a, we'll see what happens, and I will make the steps 100, and we will see what happens now. Okay, so you have to repeat the number of repetitions, the sides in the so you have to repeat the same instruction, uh, similar to the number of sides, and then the angle. So how do you calculate the angle here? So if you uh, so do you have any formula to do this? So given the number of sides, so you want to do it for 10. So what do you do? So what is the angle should be for a regular polygon with 10 sides? So there are two answers. One is 36 and the other one is 144. Which one is correct? So the angle you want to change is, so you are pointing to this direction and you have changed the angle by here 45. So that is why you have changed the direction to here. So you can see this in this, the beetle changed the angle always by 45. So I will put the weight at the end. Anyway, you can change it, doesn't matter. So so you can see the angle changes with this one. So if you want to do it for 10, so we will see what happens when you do it at 10 without changing the angle. Okay, so this is what happened. Okay, so I have to change the angle, and you can see if it is 8, it is so at when you do one whole circle, it should come to the same place. That means you should rotate this beetle 360 degrees. So, so if you do it at 8 steps, you have to do it 45 because 360 divided by 8 is 45. So here if it is 10, you want to make it 36. We'll see what happens. Oops. It went this way. So I will make the length of the side a little bit smaller, maybe 80. Okay. So you can see now uh, it's becoming a uh, polygon with regular polygon with 10 sides. So I want to draw a circle. So how do you draw a circle with this now? Any suggestions? So what is a circle? So you cannot draw a perfect circle, but you cannot draw a circle and draw something which look like a circle. So any suggestions? Okay, circle. Yeah, there are answers. Circles you can draw with circle is a polygon with infinite sides. That is the proper definition. Okay, so one has answered. So the number of sides should be infinite and the angle is 0. Okay, so that is the mathematical definition. Okay, but the computer cannot do it. What's the reason? So if you put it here the infinity and here 0, this program won't work. Okay, the computer is not cannot uh, doesn't understand infinity, and it's that is the difference. Okay, that is the difference between the computer and the human. The human can understand the different concepts like infinity and 0. Okay, the 0 the computer can understand, but infinity is difficult. Okay, so here we have to approximate. So this is the one of the most fundamental concepts in computer programming. So we cannot uh, have the exact solution or the exact model uh, as in a real world. So if you try to abstract or try to create a computer model, we have to approximate. Okay, because the computers are finite. Okay, so here what we want to do is we have to have a reasonable approximation. So that is what engineers are doing. Okay, it should be reasonable. So this is not a reasonable approximation for a circle. Okay, so we will see. So we will make it 20, and if you make it 20, it should be 18. Now we'll see. Oops. So I will make it 40 as well. Okay. And the next time I will make this waiting point 3. Otherwise I have to wait for a long time. Okay. So do you think this is a very good approximation for circle? Okay. It's not smooth. Okay. So you have to when you increase the number of sides, you have to make these side length smaller. Otherwise, your polygon will be very large. Okay, we'll move to maybe 40, and this is 9. Oops. And I will make this one 20. Otherwise, it will be very large, twice as this. Okay, it will take twice as the time now because you have, I will make this 1.1. The wait time. Okay, so now it is almost like a circle. So we can see, say this is a circle. Okay, so we will make it little bit maybe 60. 60 divided 360 divided by this one 5, maybe this one 15. Oh, it goes outside, but it's okay. Maybe 10. Okay, so I think this is reasonable enough. So many people have told make it 360 and make it 1, and maybe I will make it 1 as well, and we'll see what happens. Okay. So it's a very good approximation, but it takes time, as you can see. Okay. So there's a compromise. You have to, as engineers or computer scientists, you have to make compromise between the speed and the accuracy. Okay. So this is maybe not a reasonable approximation. So it's a very good approximation, but in real the real world, I mean the computational world, it may be not. Okay. Okay. So maybe for us it's enough to make it 60 and maybe 5. So this circle is all sorry, if you make it 5, this would be 6. Okay, so that would be enough, I guess, for us. You can see you can see it as a circle. Okay. Okay, so this is the trade-off between accuracy and the uh, speed or time or resources. Okay, so you have to make an approximation when you are writing programs. Okay, yeah, we can remove the wait time. It will make it faster. Uh, so you can do something like that, but still it will be slow. It will make it uh, say 360. Sorry, but still it will be slow because you have to implement the expressions one by one. So after first expression, you have to uh, load the second expression. So there will be time delays in the computer. So it's not the same. So if you increase the, so here we have uh, executing 360 times 2. So these each expression will be repeated. So 760 720 operations expressions will be executed here, but if you make it 60 and maybe this one 5 and this one 6, so now only 120 uh, instructions or expressions. Okay, so So this is faster because but even we have removed the weight, it will take time to implement these expressions. So earlier we had to implement 720 expressions, but here uh, only uh, uh, 120 expressions. Okay. So now maybe I will make it maybe 7 or something. Make it a little bit bigger. Yeah, that would be fine. Maybe I will make it to 0 and 0. Oops. Yeah, that would be much better. Okay. So now I want to do draw another circle on top of this maybe. How do you do that? Okay. So I will copy this one. Control C and Control V. It's the same thing. So I can draw two circles now. Okay. So before drawing the second one, I want to maybe turn a little bit. We'll see what happens. Okay. Okay. So now I want to do this maybe several times to make a pattern. So how do you do it? So I want to repeat this. I want to do the same thing by changing a little, drawing the circle, changing a little, like I want to draw a flower or something like that. Okay, how do you do it? So you want to add these the same blocks again and again. Okay. Yeah. So how do you do it? Yes. As you can see, you can use another. So we can another repeat blocks. Okay, you go to the controls, repeat, say 2 times, and you make it here. So now what happens? So this one, so this repeat block, as you can see, will draw the circle. Okay, so it will repeat 60 times, move 7 and turn 6 times. So this is same as this. So this one will draw this circle, as you can see. Okay, and what I want to do is repeat this drawing circle block 2 times, and after each time I want to turn my beetle 15 degrees. Okay, so we'll see what happens now. First time, second time. Okay, so you can do it maybe 10 times. 10 would be better. And I want to change it for 360. Okay, we'll see now. Okay, so you can see now it's a nice pattern. Okay, and so you can see now I have my same data and I have changed the control flow. So here you can see it's not linear. So when you start here and you come to these repeat blocks, and here you go in circles, and for each repeat blocks you have two repeats. So for each of the outer repeat blocks, you repeat this uh, uh, inner as well. So how many instructions are repeated from here? Okay. So how many instructions are there? So can you calculate? So how many instructions? So one expression is say this one and this one. So we have two expressions here, and we have another one here. So blue ones are expressions. So how many expressions will be executed between these two repeat blocks? So just type the uh, expression. So you don't want to calculate, just type it. How many expressions? So there are so many answers. Just type the expression. Okay. How many times? So these two expressions will be repeated inside this 60 block. So, so if you want to get the fundamental about computing, so you have to calculate this stuff. So calculator. So I will take the calculator here. Okay. So you have to repeat 36 times. Okay. Okay, so this one is not scientific calculator. I don't have. Okay. Okay, so 36 times you have to repeat the inner blocks. So what is the inner block? Inner block has another repeat plus this one. Okay, so it is 36 times. Okay, so it is 36 times what? So the outer box repeats 36 times. The inner blocks, you have this one repeats. So this block repeat only 36 times, but this repeat blocks also repeats 36 times. So 36 parentheses 1 plus 60 into 2. Okay. So that is 36 multiplied by 1 plus 120. 36 multiplied by 121. So what is the answer? 36 multiplied by 121. 36 multiplied by 121. Okay, so in here there will be 4,356. So expressions repeating inside this two repeat blocks. So if you cannot understand that, okay, how we get it, you haven't understand how this repeat blocks work. Okay, if you understand that that answer to 4356, how it is coming, you have understood the these two repeat blocks. Okay, so what we did was, so this is drawing circle, so it repeats 60 times these two, that is 120, and then you have 121 from here to here, so that 121 will be repeated 36 times. Okay, okay, so any more questions? Okay, so so you don't have any questions, it seems. um, so I will ask a question. So how did you, so I will ask a question, how did you find scratch? Simple and interesting. So I will give you some answers. And not important. Okay, so you can answer about this. So there's a question about why did you put a point in the direction? So this point in the direction means it's not a putting a point, it's pointing. So you point means so the meaning of point here is not the dot point, it's pointing in the direction. Okay, so that's not a point in the direction. So in this point is not the dot, it's the direction, the pointing. So when you turn into a place, so we say point into a direction. So that is the meaning of this point, not a dot. Okay, so we move this, we turn this beetle in the direction of 90. Okay, that is the meaning of that block. Okay, so if you remove that, what will happen? It will be the same direction as, uh, so if we remove that, and we can say, we can change this. So it will start in the current direction. That is the difference. So if you want to start in the given direction, you have to rotate that beetle to a certain direction. So if you write that one, now you can see start in the current direction. So if you want to stop that, and if you want to point in the direction this one, so when you start, it will start in the this 90-degree direction. So it will start in the same direction. So now you can see it start in the same direction. It started in the same direction. So there are some problems for some. It's not working. So you can ask that question in the discussion forum, because we cannot. I cannot download that JPEG here. So I can answer those questions. So if you have any question, you can post it in the discussion forum in the LMS. So then we can I or the others also can answer the question. So it will be better. Okay. So just ask in the discussion forum. Okay. So so it seems many of you found this interesting, and some of you have found it simple. Yes, it's simple because it has made this to make it simple. Okay, so you can learn a lot of concepts using these Scratch. Okay, just try, but you can do very complex games using this as well. Okay, so okay, so if you have any more questions, uh, you can, if it is not working or anything, you can just ask that question in the discussion forum, and we will try to answer. Okay, then if you don't have any question, we will stop the session, and you can we will meet next week, and uh, start start learning some more fundamentals. Okay, thank you for participating, and I will wind up the lecture now. Thank you very much.